want to talk to you about Ferryfood Group, which is me and Jameson, who was there connected. And we are the commercial arm of both software, and also we provide consulting and training services. So in case you need anything from us related to these services, we are here to help. ModelRisk is simulation software on top of Excel. Here you have some example clients. Now we're going to dive a little bit deeper on what ModelRisk can do. So ModelRisk is a Monte Carlo simulation add-in on top of Excel, right? And what you can do, and this is what we're going to see today in these logistics models, right? You will have a series of variables like the ones that I have here, variable A, B, and C. And these variables that could be, for example, the logistics cost. This could be the consumption. Let me change color. This could be consumption. Imagine consumption. This could be price of gas. The other one, right? Price of gas. The other one could be distance, etc., or the probability of having an issue in the route, etc. So these types of things, these are normally generated as deterministic variables into a model. What the Monte Carlo simulation permits is that you can replace all of these variables with distributions, and these distributions are going to be generated samples during the process, and these samples are going to be injected into the model. So for example, here, let's say that this variable A could be a normal distribution, this could be a uniform distribution, this could be a triangular distribution, right? And during the simulation, what happens is that you will have samples that are going to replace these variables. As these samples are replacing these variables, you're going to recalculate the model. The model could be, for example, the total cost of daily routes, and this is the one that we're going to see today, right? Total cost of daily routes. And what happens with this is that this cost is going to be refreshed or recalculated thousands of times, right? Thousands of times. So during this recalculation, you will have that, for example, the cost is 5,000, then it's 5,300, 6,000, 7,000, right? 4,900, etc. So what's going to happen is that you will have all these potential costs set up and added as a final distribution. So you see, this is the typical schematics of this Monte Carlo simulation. You add the distributions there, you run the simulations thousands of times, and then you get the results. And the results, you analyze them with a histogram, right? And this is exactly what we're going to see today. Every month, we do a different Monte Carlo simulation model. Why is that? Because we want to show the ability that has ModelRisk to cope with all these different combinations of models. So before I go there, I will show you our YouTube channel where you can see here this one that reads, let me see here, playlists, and let me go to the both software playlist, and we have 10 videos now, right? Like this, right? So this is us, right? And we have workforce planning, cost budgeting, risk register, cost estimation, NPV calculation, moving from at risk, right? 4 demos in one, etc., etc. Project portfolio model. So you have all of this there, and I will ask you if you can subscribe. That would be great if you can subscribe, right? And we're going to set up this model as part of this collection as well as soon as we edit it, right? Now, let me share with you the model. The model, as I said before, is a logistics time estimation model. As with any model, you have some parameters. For example, the hourly cost of the driver, the overtime, if they have it, the multiplier of the overtime, fixed cost per trip, for example, $120. And you have some distributions here for the variables like the speed, the fuel price, the fuel consumption, the delay of the hours, etc. So this was initially static, right? And then we're going to convert all of this to dynamic, right? To probabilistic. This is what we're going to do today. Now, what we will do, right, is also we will have a delay probability that is also static, right? is also static that you can change to a distribution, right? How to obtain what distribution? Okay, good. So I'm going to answer your question during the call, definitely, Jacob, right? So what we did, you see that we use these values are as somehow static values. Remember that in Monte Carlo simulation, as I show you here, you can set up any number of distributions for any number of variables. So you can have thousands of variables and you can have hundreds or dozens of variables. It depends how the degree of complexity that you want to give to your model, right? And then here, what I did, I generated some routes there, right? So the main idea and the model is very simple. The model goes like this, right? You have a headquarters, which is here, and then you have 7 routes that your trucks have to go back and forth one time during the day. Of course, I could do more complex than that and say, well, of course you can, the shortest route I will do it 3 times a day, the longest it could be only one, etc. But I just wanted to go back and forth one, just for you to know how to do it, right? I didn't want to set up more difficulty there, right? And I generated a little map with that and a little schematics as well. So the good thing about this is that with a model that it's not very complex, you can set up a lot of complexity, right? And you will see how. First of all, you have the distance like this, right? You have the distance. I have schematics here, right? You have the distance, which is, for example, 320 kilometers for route A. This is the probability of having a delay that you can have from historical information, right? And what you have here is the speed limit from in miles from 50 to 90 miles, like this, right? Then you have the fuel consumption. I'm sorry, the fuel price in the route and the consumption per kilometer, right? Liters per kilometer, right? And if you have a delay that you have a 25% probability of having a delay, then you have a delay of 1 through 4 hours, right? This is route A. Let's go with route B. Of course, I'm not going to do the A route. I just want to show you what's the difference. Route B, as it says here, it's a mountain route, right? And this is as a mountain route. It has less distance. You have less probability of a delay, but take a look here. The speed is less, right? Your consumption, your price, I'm sorry, the price for fuel is higher and the consumption is higher because it's high and low, high and low. And if you have a delay, even with a smaller probability, it's going to last longer because you don't have escape routes, right? You're in the mountain, you just have to wait. So these type of things, you can set it up like this. Very simple. Now, what we did, we transform all these routes. You see that you can have, this is like your control panel. This is all the routes that you have. And what we did, we generated this cost estimation sheet. The cost estimation sheet, what it did, it took a triangular distribution, for example, for the speed. So that means, and I'm going to show it to you right now, right? That means that you can simulate, for example, how route A is going to work. So let's, every time that you press F9, right, it's going to change like this, you see? So in this case, you have the speed limit. Remember, was between 50 and 90. So you will have values between 50 and 90. Then you have the fuel price that is going to be between 1.1 and 1.9, and the consumption like this, right? So these types of parameters are going to change according to the distribution that we set up. So as Jacob was asking before, right? It depends on the information that you have, the distribution that you will use. Now, if you want to, this is going to be your first interaction with the model, right? This is version 1. So of course you can improve it. Of course we can make it better. Definitely. The main idea here is that in the first iteration, we use simple distributions like the triangular, the PERT distribution, which are here, you see? Why? Because we are just getting used to the software. If we have historical information, we can use what we call a distribution fitting, right? If you don't, you can just go with benchmarks and things like that. Right? Now that you have this, right, also you have the probability of a delay like this. And also I saw what you wrote, Stephanie, which is really, really great. The probability of getting earlier. that I think that we should add it to the model. Right now, it's not added to the model. So for example, here, for route A, we didn't have any delays. Let's see, let's keep running simulations for route A until we get A1, like for example here. So in this delay, we got a delay of 1.7 hours. So the total time that we drove was the total time of the 320 kilometers divided by speed limit, right? But speed, the average speed that we have, plus the delay, right? So what happens is that I have to pay the labor cost for the 7 hours, the $35 that I think it was. Let me see, parameters B6. Yeah, it was $35. So the $35 I have to pay for the 7 hours, right? Plus the fuel cost, right? Now you see, you have the consumption, you have the price, you have the fuel price, right? Plus the fixed cost of the trip. So now you have $500 more or less in total cost for that particular trip, for only that trip. Now you take a look and you have routes A through HQ to F, right? All of them together, how much they cost, right? And also coming back. Right? So that means that, why? Because even though, and I didn't want to multiply this by 2, because sometimes depending on the hour, maybe the time of the day where you go from the headquarters to route A, it has a lot of traffic, but maybe you come back late night. And as you come back late night, perhaps you don't have such a probability of delays, the delays are smaller, etc., etc. So you have also the ability to set it up like this. Right? For each one of the routes, like I have here, right? I generated this calculation, right? So you have the number of hours for the route, and you have the price for the route, right? So what I did as a simple, thing, I generated the total time hours that my trucks are going to be used, and the total cost that are going to be used. And now I am going to generate it and run a simulation. So what the Monte Carlo simulation process does, right? I will run this thousands of times. Once I finish, let me run it here. I'm going to run 1,000 times, right? With ModelRisk like this, I will run it. And what this is going to show a lot of things. First of all, I want to focus on the totals, right? Remember? So I have the total cost is going to be seen like this, right? So my total cost is going to come from 4,000, no, from 3,000, it's here, you see? 3,000 to almost 5,000, like this. This, remember, this includes the cost of the delays, right? So this includes the cost of the delay. So you will have this 3,000 to 7,000, like this, and also the total hours. So this is the total hours that my trucks are going to be, from 36 hours to 70 hours, right? So you have a lot of variability there, right? So these are the types of things that you will be able to see. Now, what if you want some disaggregation? What did I do? I did generate this Bose output for the total number of hours and Bose output the total cost here, right? With that, I can calculate the totals, the ones that you saw, right? 40 to 70 hours, and I think it was 3,000 to 5,000. But for each one of the routes, you see here, I have also a Bose output here, a Bose output for the cost and for the time, right? So that means that while the Monte Carlo simulation was running, I was also able to generate, right? To generate the cost of each one of the routes. So for example, if I want to see the cost of route A back and forth, so I can say cost A, HQ, HQ to A, like this. If I like, I can see it in a different way. I can see it with a different chart like this, which is more or less the same cost, even though I can generate it as a box plot here. And I can see, you see that the box plot is better because it lets you see what is the mean, what happens there. So we need to see how is it that I can improve my HQ and A to HQ to see if it's better. I can compare cost of A, B, C, D, E, F, like this, for example. This is my return cost. So take a look here. Cost of F returning to HQ is going to be super small compared to the cost of A. So we will have to see why. And that's the idea of this visualization, right? That you have the whole portfolio. If you like, I can take a look to all of the costs here, right? Maybe it's too much information, but if I like, I can go all the way with this, right? So the main idea here is that you will be able to analyze from a different point of view. For example, take a look here in Route C, take a look how long this could be. So maybe there's a big opportunities of perhaps or big potential delays. So we should do something like that. Maybe the route is not good enough. Of course, what I didn't have here are two things. One is what Stephanie said, which is the opportunity side, right? I can put a route here that says -2, -1, -3, for example, right? That means that this is going to be a potential for arriving earlier. That's one thing. And the other, I didn't put here how much is the load, right? Because if my trip is going to cost me $500, so at least I will have to carry $500 to cover for my costs, right? Otherwise, it's not going to be profitable, right? So the main idea is, well, how is it that we're going to do it? Because this, you can say, oh, but it's very simple to do it to do it 500, but 500 every day. Remember that I have to pay for each one of them $120 plus the labor cost for the fuel cost. So the difficult part is to have very high occupancy through the days, right? Now, this is not included into the model. The model is mostly a cost estimation model, right? So you have this operation simulation here that you have. Plus, when you run the simulation, ModelRisk has these things called, you see, VOSIM mean, so you can get the average. You can get percentile 50, percentile 90, the cost, you see, the mean of the cost, the probability of having an overtime, etc. So what happens is that you have here, for example, the average time. Remember that the only statistic that you can sum up is the average. So you can sum up and say, well, during the day, I have 50 hours in average of my trucks running. Remember, it was between 40 and 70. Now I have 50. And my average total cost is going to be 4,000. So if I want easy measures to put in my head to do some calculations, we'll say 50 hours and $4,000. That's what it costs my operation per day, going again back and forth one time. Of course, if I have this route here, which is 50 kilometers, right? That's why the route F was so cheap, because it's only 50 kilometers. Maybe I have to do this 4 or 5 times a day. And this is, of course, I will let you do to enhance the model, reproduce it, etc. So this can be done, right? So this is one model that I prepare, and then I prepare a second model, which I like a lot, which is the typical inventory model. Right, so let me close this first one. One thing that you need to know about ModelRisk is that it will run simulations in all the models that you have open. So that's important, because sometimes we have a lot of models open in Excel, and you will say, oh my, but this is very slow. No, it's because you have maybe 10 sheets open and you're simulating only one, right? Now, how is it that we can do this? This is the typical inventory replenishment model, right? You start with a current inventory, right, which is going to be 300 items, which you have here. You have a damage rate, right? You produce these 300 items, but I'm sorry, you buy these 300 items, but they have some damage rate here, right? And then you have the operational limit. The moment that you have less than 180, right? That means that you have to reorder again, the reorder point, right? Then you have the demand. So the demand is going to be, you see here, a normal distribution. How do you set up a normal distribution here, right? It's a normal distribution, right? With mu, or the mean, equal to 80 and the sigma equal to 20, like that, right? So it could be 60, it could be 70, 80, etc. Right? So what happens is that if you have a demand of 101 and you have more or less 1% of damage rate, that means that you need to ask for 102. Why? Because you know that it's going to be damaged anyways, right? Then you have a theoretical new inventory of 198. Why? Because you have 300 and now you have to consume 198. As 198, right, is yet greater than the reorder point of 180, you don't have to reorder. So that's why you have 0. Then you don't have order cost because you haven't asked. You have a holding cost because of the holding cost of the items that you had before, right? So your total cost is going to be 32. Now, what happens later? So you have 198, which are here. Then after the 198, right, you have a demand of 87. This demand of 87 that you have here, let me make it a little bit bigger. This 87 that you have here is going to generate a theoretical new inventory of 110. As you have 110 and it's lower than the reordering point, right? What's going to happen is that you're going to ask for the reorder. Reordering is going to be 120 items. And then, of course, you're going to pay the cost of that and pay the holding cost as well. You're not going to be shortage, no shortage cost because it was never below 0, right? I mean, you always could fulfill what they had. So what happens here, and you can see that in the graphic, let me show it here in the graphic. Oh, show it in the graphic, is that you will see how the reordering works and how it is well prepared, right? You have 180 as the replenishment point and 120 as the order. So what you have in blue is the real inventory. Take a look here. The real inventory, which is always almost there, less than 180. You see that what I am doing is that this is weekly. And what I'm saying is that the reorder point, the moment that I ask and between the I ask and the goods come, is going to be 1 week. So that's perfect because I don't have any shortage, right? The little dot line that you have here is the theoretical inventory. What happens if I don't have this? And the red bars are the reordering points, right? So again, I can run a simulation here. Let me do it. You see that it's a different one. I will run one simulation. You see here, and then I will set up and tell you what happens with the other model, right? And what I did here is, of course, how many reorders I have. You remember I have a VOS output there, and how many total, how much is going to be the total cost. So I run it again 1,000 iterations. Right? And you take a look. What you have here in the operation, you have the total cost. You see, the total cost could be between 730 and 854, which is this. Why is it that you see it like that? Because it's in discrete jumps. You always order the same, right? 120. Otherwise, you can see it like this. That's going to be like a ladder, right? Like that. And you can see the total reorder, right? The total reorder is going to be between 720 and 1,000, like this. So you will know how many you have to reorder. So you will have to have the cash to do it. This is very helpful because it gives you the cash. But here we were assuming a very heroic thing, that was that every time that we got it, we got it in the next week. So we never had any shortage. So let's go to the next one. And the next one is an operation lead time, where the lead time is going to vary like this, right? So remember, in the lead time before, we always have 1, but here the lead time is 3 weeks, 2 weeks, 1 week, etc. So take a look here. I have a current inventory of 300. If I have to reorder, my lead time will be 3 weeks with a delivery week in number 3. I didn't have to reorder. You see, reorder 0, which is fine. But here, I have a current inventory because I have a demand of 52. So I have a 250 demand here now. And now what's going to happen is that I will have to reorder whatever it takes. Why? Because my inventory is not enough to hold it, right? I have 250, right? I have the demand that's going to take me to 200, right? And in this case, the service is okay, but I will have to reorder. Why? Right? Because my potential inventory is going to be less than 180. So I have to reorder, but the goods come in 2 weeks. So what this model does, it takes into consideration of the delays of the model. So take a look here. Remember, here you never were below the reorder point. Here you can because you have the leads. So you see, it is very difficult. Sometimes you don't have it. You don't have issues. Sometimes you have issues like this, right? So what I did to generate the best model possible, right? I generated this service okay. This service okay means that when you ask, for example, you're asking for 94, you have enough units or not, right? Or you have some type, right, of I mean, you have partial or total coverage of your demand. So when you have partial demand, it's a 0. When you have total demand coverage, is a 1, right? So what I did, I generated the average of this, which is the service that you have there, and I calculated the service. Same thing, I calculated the reorder dates and the total cost for that. Once you have that, what you're able to do, you're able to run the model. Take a look here. So if I run it with 150 and 200, imagine the initial order was 180 and 150, right? So I run the model, current simulation of the model. I will say yes. And what I will do, I will take a look to my service rate. So my service rate here, right, is going to be around, you see, 27%, 28%. It's not very good. So what I did, and this is something that we cover in another session, you see, 28%. We cover what we call scenarios, and I created 10 scenarios, which are here, right? Thank you, Omar. Not a problem. Thank you, Omar. It's going to be recorded, so don't you worry. Right? So what I did here is I generated what we call a sim table, right? So I'm going to do this. I'm going to say I'm going to run 10 simulations like this, right? Yes, and for the cumulative order, I'm going to do a Bose sim table of all the order like this, and the reorder point, I'm going to do the same. It's Bose sim table for this. So what this is going to do, right? It's going to set up simulation number 1 with this simulation number 3, 4, 5, 7, etc. So it's like you do it 10 calculations, 10 simulations automatically, right? I'm going to lower the number of variables, the simulations, only because the complexity, because it takes time. So the moment that you start, you will see that it gets 10 iterations, 10 simulations. You see, simulation 1, 2, 3, 4, 5, etc. And what I did here using this Bose sim mean or the Bose sim percentile, I generated a table that's going to be the one that tells me what's the best scenario, right? You see here, so now I have 10 simulations, remember? I have 10 simulations. And what I will be able to do is I will be able to see the cost and what is, you see how interesting this gets? What is the best, in this case, the best scenario for me? So the best scenario for me will be the one that it goes more to the right, which has better service. and it has the lower cost. That's the best scenario, right? The one in green, I mean, my green area will be here. So maybe what this scenario or this scenario would be the best. So perhaps you see, moving the theoretical inventory or the real, I'm sorry, the queue order to 180 and the reorder point to 200 is really good because increase the service to 43%. And moving even to 200 and 200, it increases the service to 48% with this cost, which is even less than that, you see? So now I will be able to search for the minimum here. Maybe it's going to be over there. Hopefully we can get service rates of 70, 80%. The idea is for me to explore that. Right? So this is a combination of what a replenishment model would do combined with sensitivity analysis. Okay, so what we wanted to do today, and I'm not going to hold you later more than that, is to show you two models related to logistics, right? One for the logistics cost, the one that I show you a little while ago, and one for the replenishment. So with that, now you know that you have another application of ModelRisk in your hand, right? So thank you all for coming. Thank you, Stephanie, for the question, and thank you, Omar, also for coming. If you have any questions, remember that we have our YouTube channel here. If you go to YouTube, Perryfield Group, I'm going to send it to you, right? And more than happy to answer any questions if you have any. If not, well, thanks again for joining.